Hello, my name is Mark and I will be talking about exponential functions. Some basic attributes of exponential functions are their asymptotes, the domain, and the range. Now, exponential functions have a horizontal line that the graph never touches, called the asymptote, and it's represented by this value, d. If d equals 0, which is shown right here, there will be an imaginary line at y equals 0 that the function will never touch, but it will get very close. The domain of an exponential function will always be all real numbers, no matter how you change any of these values here. And the range of an exponential function will be d to infinity, d being from the equation shown up here and here. The parent function of an exponential equation is y equals 2 to the power of x because the b value here has to be greater than 1. It can't be 1. This graph right here represents how the b value will how the x value will change according to what the value of b is. So here, with it being 2, this is what the x values would look like, and this is how you would plot the graph.
Hello, I'm Daniel. I'll be explaining exponential functions, transformations. Exponential transformations has horizontal, right and left, vertical up and down reflection, vertical stretch, horizontal stretch, vertical stretch or shrink, horizontal stretch or shrink. Horizontal right and left is decided on the C right here. As you can see, if it's a negative here, so if it's -4, it'll be to the right 4. If it's +4, it'll be to the left 4. Vertical up and down, since there's a plus here, it'll always be, let's say there's +4, it's up 4, -4, it's down 4. Reflection, if there's a negative on B, it'll be reflection over the x-axis. If there's a reflection on the x, it'll be reflection over the y-axis. Vertical stretch, this is A right here. It's always bigger than 1. Vertical shrink is when it's between 0 and 1. And horizontal stretch is on the x here. So it's the same thing as vertical stretch. It'll be bigger than 1 for stretch, and it'll be between 0 and 1 for shrink. Here are some examples of transformations. We have vertical stretch of 2. It goes 1, 2. Start it up 2 for some reason. Start vertical stretch of 2. Shift right 2. So we start it right here at 2. Shift up 1. The asymptote here is at 1. And you have a horizontal stretch of 1/2.
Here is our first example question. 9 to the power of 8 minus p equals 27 to the power of p minus 3. To start, you would convert 9 to 3 to the power of 2 and 27 to 3 to the power of 3 in order to be able to cancel these 3's out, which is the next step. And then from here you can just distribute. Once you have it in this form, you can solve it as a normal equation, which will mean you also have to include the solution sets.
And here's example question number 2. It's going to be e to the power of x squared minus 4 equals e to 3x. And then we just cancel out the e's to get this equation right here, x squared minus 4 equals 3x. And we just bring the x over to give us this, so we can factor it. X squared minus 3x minus 4 equals 0. Our factors are going to be x minus 4 and x plus 1 equals 0. And to solve, you use the rules, this equals 0. So x minus 4 equals 0 or x plus 1 equals 0. And x equals 4 and x equals -1, and this will be your solution.